All right, so for 9b, this is really going to be solving quadratics by factoring. So we've actually already covered how to do factoring. So a lot of this lesson is just kind of applying what we've already known or what we've already learned in a previous lesson. So just to kind of start off, we're going to kind of go back to just solving general equations. So just recalling, say if I have x minus 5 equals 0. If I were to solve this equation, you have to do your inverse operations. So because I'm subtracting 5, I'm going to add 5 on both sides. All right, so that means our final answer here, we're going to have x equals 5. I promise this is actually going somewhere. We're not just solving equations. All right, so for number 2, same idea here. But remember for inverse operations, whether you want to use PEMDAS or GEMDAS, it doesn't matter. So if you use PEMDAS, it's parentheses. If you use GEMDAS, it's grouping. It doesn't matter. Same difference. Either way, just know we're doing inverse operations, which means we have to start with addition and subtraction. So we're doing inverse operations going that way. All right, so we have to get rid of this addition first. So to do that, I'm going to subtract 3. So we're going to have 4x equals 24. And now because I'm doing 4 times x, I want to divide. I want to do the opposite. So when I divide, we're going to have x equals 6. All right, moving on. Same idea here with number 3. So first off, I'm going to subtract 4 on both sides. I'm going to undo the addition. So I'm going to have negative 2/3 x. That's going to equal 4. Now, because of this fraction, I want to get rid of this denominator first. So that's negative 2 divided by 3. So I want to multiply both sides by 3. So I'm going to get negative 2x equals 4 times 3, which gives you 12. And now I want to get rid of that negative 2. So I'm going to divide both sides by a negative 2. All right, so here we're going to have x equals negative 6. All right, so we're going to be applying solving equations and factoring into this exact lesson. So I promise solving equations was actually relevant. It wasn't just kind of a random throw-in. All right, so just some kind of reiteration of some quadratic vocabulary and terminology, which if I constantly am throwing it on the notes, I promise it means it's important, which means you have to know it. All right, so the blank of a parabola is the highest or lowest point in the parabola. So I would actually suggest pause here and actually fill in as much of this as you can, and then just kind of watch the video and see how much you got. All right, so the vertex of a parabola is the highest or lowest point. The axis of symmetry is the vertical and dashed line that passes through the vertex. Now the minimum and the maximum respectively. So let's do maximum and say orange. All right, so the minimum, if you remember, is your lowest point, and your maximum is going to be your highest point. All right, so the solutions of a quadratic function are going to be where the parabola crosses the x-axis. All right, so speaking of solutions, you can have up to exactly 2 solutions. You can have no real solution, which is 0 solutions, 1 solution, or 2 solutions. All right. So the solutions of a quadratic function, they are written as either a coordinate or they are written as, as x equals some value. All right. So your solutions have various names. So one of the names is literally just solution. So there's 4 names. So solution is your first one. Then you could have what we call a root, a 0, or just an x-intercept. So it could be any one of those. All right, so now let's say I give you a quadratic equation and I want you to find all the zeros. So essentially it's saying find where it crosses the x-axis, but in this case, I'm not going to give you a graph. I'm just going to give you the equation. All right, so let's say I give you this quadratic equation in its factored form. So in its factored form, what you're going to do is you're going to take that equation, you're going to take its components, and you're going to set each component equal to 0. And then you want to solve each of those components for x, or whatever the variable is. So this is where you're actually going to start solving equations. So I'm going to do the inverse operations, which means I'm going to have -7 on both sides. So I'm going to have x equals -7. And over here, I want to add 3. So I'm going to have x equals 3. So your two solutions here are -7 and 3. So keep in mind, we're setting it equal to 0 and we're solving. So we're actually solving. We're not just simplifying and finding the factors. We are actually solving and finding those exact x values. All right, just keep in mind, this is given the factored form, but other questions, you actually will have to factor them. So you can do grouping or whatever method you prefer. It doesn't matter. All right, so let's say I do grouping on this one. So I'm going to have A1, B -14, and C, which is 45. All right, so if I do A times C, we're going to have 1 times 45, which is 45. So when I do the factors of 45, we have, say, 1 and 45, 3 and 15, 5 and 9. So I want these to somehow add up to -14. So keep in mind, because they add up to a negative, but they multiply to a positive, what that tells you is they all have to be the same sign, and they're all going to be negative. So because of that, the factors we want are -5 and -9. All right, now here's another thing. If you're having trouble finding your factors, one thing that you can do, a little trick in the calculator for you. So this is just on the TI. I'll show you on the Casio as well. So on the TI calculator, if you have math print or not, you can do alpha y equals, press 1, which is down here, and it opens up a fraction. So because we're finding the factors of 45, you can actually type in 45. So 45, and then we're going to divide it by x. So this is what your function should look like. If I can actually press the button and actually hold it. All right, so that's our function. So we want to go to the table. So I'm going to press second graph, go to the table, and what we want to look for are the whole numbers. The whole numbers are going to represent your factors. So for example, over here, we can't divide by 0, so it's just going to be an error. But here we have 1 and 45, and then down here we have 3 and 15, and then we have 5 and 9. Now keep in mind, see how we have all these fractions over here, these kind of gross numbers? That tells you that it's not going to be a factor. So that means you have to move on to the next value. So once they start repeating, so now here, once we have like 9 and 5, then that tells you that you found all the factors. All right, so that's if I do the TI. Now on a Casio, it's the same concept. So on your menu, you want to go to the table, which is function number 7. So you can literally just press 7 if you want to take you to the table value. So for the table function, you want to plug in the same function as before. So to open up a fraction, I'm going to press this button right here, open up a fraction, and I want to type in 45 divided by, if I can actually do this mirrored, but nope, 45, and I want to go over x. So your x value, your button for x is right here. You press that, and you have 45 over x. All right, so I'm going to press enter, and I'm going to go to F6 to get to the table, and same idea, you're looking for the whole numbers. So here we have, say, -9 and 5. So that's actually the factors that we're going to use. So once again, you're looking for whole numbers. Those whole numbers are going to represent all your factors. Okay. All right, so over here, I'm going to split the middle using those two factors. So x squared minus 5x minus 9x plus 45 equals 0. All right, so I'm going to go through this kind of fast since we've already done factoring. So I'm going to do grouping. So x squared minus 5x negative 9x plus 45 equals 0. I'm going to take out the GCF. So of the first group right here between x squared minus 5x, I'm going to take out that x. So that means I'm going to have x minus 5 left. Now in your second group over here, I'm going to take out a negative 9. So remember, if your first term here is negative, you have to take out a negative. So I'm going to take out that negative 9. We're going to have x minus 5 left. So once again, your two binomials here in parentheses, they have to be the same. So now I'm actually going to take out that binomial that they have in common. So I'm going to have x minus 5 and x minus 9, and it's going to be equal to 0. So I'm going to take both of those factors, or both of those components, and set them equal to 0. And you want to solve those for their corresponding x value. So over here, if I add 5, so it's x equals 5. And over here, I'm going to add 9. So then we also have x equals 9. So our two solutions here, we have x equals 5 and 9. Okay. So really just know this isn't a lot of new stuff. You should already know how to factor. The only new part is actually taking those factors and then doing the extra step of setting it equal to 0. So another new part is going to be how the equations are possibly set up. So the equations may be set up in a specific way where you may actually have to rearrange. All right. So now for this next part, number 3, we have a difference of squares here. So if you remember your difference of squares, what this means is I want to take these two binomials, and the first term is going to be the square root of the first, which is n. And then I want the square root of the last, which is 4. And then your signs, you have one with plus and one with minus. All right, so now I'm going to do my components, set them equal to 0. So n plus 4 equals 0 and n minus 4 equal to 0. So when I do my inverse operations, subtract 4, so we're going to have n equals -4, and I'm going to add 4 on the other equation. So you get n equals +4. So you have a couple different ways that you could write this. So you could have -4, 4, but there's actually a very specific way I would much prefer you to write it. So notice how we have the same value of 4, but we want both the positive and the negative value. So there is actually a way to combine those into one value. So you could actually write it as a plus and minus. Plus and minus. English is hard. All right, so a positive negative sign, which is written right here, it just represents two values. It represents the positive value and the negative value of that number. So I would highly recommend starting to use the plus minus sign whenever it is applicable. All right, so moving on to number 4. All right, so this is another special case. So the reason you can kind of see that is you can take the square root of the first and the square root of the last. And then you want to keep the sign of the b. All right, so I'm going to have w minus 9 squared equals 0. Now I want to check it first. So remember, you have your two AB that you need to check. So your A value is 1, and your B value is 9, or -9. All right, so if I do my 2AB, we get 2 times the A value of 1 times the B value of -9, and we get -18. So that -18, it matches our B term, so we're good to go. All right, so what I'm going to do now is I'm actually going to take all this, I'm going to come down here, and now I'm going to solve it for 0. All right, so I want to get rid of that square root. Now the opposite of a square root, nope, not square root. The opposite of the squared, this is what I want to get rid of. So I'm going to take the square root of both sides so I can get rid of it. So I'm going to have w minus 9 equals the square root of 0, which is literally just 0. All right. So in this case, when you solve it for w, if I add 9 on both sides, that means we're going to have a solution value of +9. All right. So what this tells us is this parabola only touches the x-axis at one point, which is the vertex. All right. So your parabola, remember, could have up to 2 solutions, but in this case, we only have 1. All right. Moving on down here, this is where your more tricky problems are going to start coming into play, where you're going to have to start rearranging, and it could be a mess. So there we go. So looking here at number 5, what I can see right off the bat is I'm looking at the numbers 3, 24, and 21. Every single one of those numbers is divisible by 3. So I want to take out a GCF of 3. So when I take out that GCF, I'm left with x squared minus 8x plus 7 equals 0. All right, now what I'm going to do next is I want to factor the part inside the parentheses here. So I'm going to go ahead and do my grouping. So when you do your grouping, you're going to have x squared. I'm going to kind of skip a few steps. I'm going to kind of transition into this. All right, so you're going to have minus 7x minus x plus 7. Then you're going to do your grouping. X squared minus 7x minus x plus 7 equals 0. I'm going to do my GCF. X minus 7. Then take out a -1. X minus 7 equals 0. All right, so your terms here, you're going to have 3 times x minus 7 and x minus 1. All right, so I kind of skipped a few steps just in terms of the explanation, so we can go ahead and get to this part. All right, so here you want to take all your individual components. So now when I say components, you want to take the 3, the x minus 7, and x minus 1. We have 3 components in this case. So what I'm going to do is I have 3 equal to 0, x minus 7 equal to 0, and x minus 1 equal to 0. So here's the thing. For your very first one over here, 3 doesn't equal 0, so we just kind of ignore it. All right, so now we're looking at the other 2. So x minus 7 equals 0. What I'm going to do is I'm going to add 7 on both sides. So I'm going to have x equals 7. And over here, I'm going to add 1. So I'm going to have x equals 1. So my 2 solutions here are x equals 1 and 7. All right. Now over here for number 6. So the first thing I want you to notice about number 6 is the fact that our equation here has a power of 3. So what that means is this is actually a cubic function, which means we could have up to 3 solutions. Your highest degree here potentially means how many solutions you could have. So in this case, we could have 3. All right, so looking at your cubic function here, if you notice, we have h cubed, h squared, and an h. So I want to factor out that h as my GCF first. So I'm going to factor out. So I have 2h squared plus 11h minus 21 equals 0. All right, so let's go ahead and do some factoring. So I'm going to find factors of a times c. So I want factors of 42 that are going to add up to 11, specifically negative 42 that add up to 11. All right, so we're going to use factors positive 14 and negative 3. So 2h squared plus 14h minus 3h minus 21 equals 0. All right, so I'm going to do my grouping. So I'm going to take out a 2h out of the first group. So it's going to be h plus 7. And in the second group, I'm going to take out a negative 3, which leaves me with h plus 7. All right, so my components here, I'm going to have h parentheses, h plus 7, 2h minus 3 equals 0. All right, so once again, we have these 3 components that we want to set equal to 0 and solve. All right, so what I'm going to do here, I'm going to have h equals 0, h plus 7 equals 0, and 2h minus 3 equals 0. Now keep in mind your h equals 0 component right here, it's already done. That's a solution. So now you just need to solve your other 2. So my other 2, I'm going to subtract 7 on both sides. So h equals negative 7. Then over here, add 3 to both sides. Hello. So we're going to have 2h equals 3. And now I need to get rid of that 2. So I'm going to divide both sides by 2, which means we're going to have h equals 3/2. All right, so just to kind of give you an idea of what to expect. So I know this might be a little hard to see because I'm doing it on my calculator, which is going to be on your very small screen. So 2 cubed plus 11 minus 21 minutes. Draw. Okay, so when I draw this on my graph, this is what you're going to have. So notice how your function here is going to cross the x-axis 3 times. So that's why we have 3 different solutions. So remember, you can press the minus button on your Casio to zoom out if you want to get a better view or a worse view. And if you press the plus sign, you can actually zoom in and get a better idea of what those solutions are. So it's really up to you. So in this case, our 3 solutions are going to be h equals negative 7, 0, and 3/2. So just a rule of thumb, whenever you're writing out your solutions, you want to write them out in order from least to greatest. So I started with negative 7 and ended with 3/2 since that was my largest one. So just a rule of thumb. All right. So looking at number 7, so this is where the rearranging is going to start coming into play. So here, I want to move everything on the same side of my equal sign. So I'm going to subtract the 15m on both sides. So I'm going to have 6m squared minus 15m equals 0. And now I want to do my GCF. So between the 6m squared minus 15m, I can take out a 3m. So when I take out that 3m, I have 2m minus 5. So once again, we have these 2 components here. So we have 3m and 2m minus 5. I want to set both of those equal to 0. So 3m equals 0, and 2m minus 5 equal to 0, and solve. All right, so for this first one, I'm going to divide both sides by 3. So we're going to have an m value of 0. And over here, I'm going to add 5 on both sides. So I'm going to have 2m equals 5. And then divide both sides by 2, which means we're going to have a solution of 5 halves. So once again, when you're writing out your solutions, you want to write them in order from least to greatest. So we're going to have 0, 5 halves. So as you can see, you can actually have fractional roots. That is a valid solution. All right. So there's number 7. All right, so number 8. All right, so I need to convert this to standard form so I can start actually factoring it. So what I'm going to do to start off is I'm going to distribute this negative 2x. So even though we have the components already separated, we really want to get it in its simplest factors form. So this value is going to be equal to 0. All right, so I'm going to have negative 2x squared minus 8x. And then I'm going to move over the 42. So I'm going to add 42 on both sides, which means here, actually, no, that's one step at a time. All right, so now I have that negative 42, and I'm going to add that over to this side. So I'm going to have negative 2x squared minus 8x plus 42 equals 0. All right, now between all three terms, I'm going to take out the GCF of negative 2. So I'll have x squared plus 4x minus 21. All right, so I'm going to kind of streamline the factoring process here. So when you factor, you should get x plus 7 and x minus 3. All right, so once again, I'm going to set all my components equal to 0. So we have negative 2, x plus 7, and x minus 3. All right, so I'm going to have negative 2 equal to 0, x plus 7 equal to 0, and x minus 3 equal to 0. So if you remember, negative 2 does not equal 0, which means we just ignore that one. We disregard it. So over here, x plus 7 equals 0. I want to subtract 7 on both sides. So we're going to have x equals negative 7. And then I want to add 3 over here on both sides. So we're going to have x equals 3. So your solutions here are x equals negative 7 and 3. All right, so this is really just a fancy way of solving equations, which we've already done. We're just doing it in the quadratic equivalent. All right, number 9. We're almost done. 2 more. So once again, you want to get everything to the same. Okay, bye. You want to get everything to the same side of the equal sign. So I'm actually going to move over everything from the right side over to the left side. Now, the reason I'm doing that is because my x squared is here and here, you want to move the smaller one. So between 4 and 2, 2 is my smaller one, so that's the one I'm going to move. All right. So to move it, I'm going to subtract it. So I'm going to have 2x squared plus 3 equals 7x. And now I need to move over that 7x. So I'm going to subtract it on both sides. So notice how this is my b term. So I'm actually going to write this in the middle. So I'm going to have 2x squared minus 7x plus 3 equals 0. So now we have our trinomial that we can factor by grouping. All right, so once again, I'm going to kind of streamline the process here. So when you do grouping, you're going to get minus 6x minus x plus 3 equals 0. So of the first group, I'm going to take out a 2x, which leaves you with x plus 3. And in the second group, take out a -1, which leaves you with x. Nope. What did I do? That'd be x minus 3. Oh, right here. My dumb self. Minus. Oh my gosh, math is hard. There we go. Okay. So our values inside the parentheses are exactly the same now. See, I had to check it. So I'm going to take both of those components. So x minus 3. And we also have 2x minus 1 equals 0. So these are going to be our two binomials, which I am now going to set equal to 0. All right, so here, once again, just solve it. So we're going to have x equals 3. And over here, add 1 on both sides. So you're going to have 2x equals 1, divide by 2, which means you're going to have an x value of 1/2. All right, so your solutions here are 1/2, comma 3. All right, and last but not least, number 10. All right, so everything's already on the same side of the equal sign, so I don't have to do any manipulation of the equations. So I'm literally just going to expand it, combine like terms, and get it to the standard form for quadratics. So the first thing I'm going to do, oh, it's actually in Vertex form. How about that? So the first thing I'm going to do is I'm actually going to expand this x minus 3 squared. So I'm going to have 3x minus 3, x minus 3 minus 12 equals 0. So when I multiply the x minus 3 squared, you're going to get x squared minus 6x plus 9 minus 12 equals 0. I'm going to distribute the 3. So you're going to have 3x squared minus 18x plus 27 minus 12 equals 0. And now I want to combine the 27 and the negative 12. So we're going to have 3x squared minus 18x plus 15 equals 0. So now here's our standard form for a quadratic. Now, if you look at the coefficients here, we have 3, -18, and 15. There's a GCF of 3, so I want to take out that 3, which leaves me with x squared minus 6x plus 5 equals 0. So now I want to factor x squared minus 6x plus 5. So once again, I'm going to kind of streamline that process. X squared minus 5x minus x plus 5. So -5 and -1 multiply to +5. -5, -1 add up to -6. So when I do my grouping, we're just going to have x minus 5 and x minus 1. I know I'm skipping a lot of steps for the grouping, but I just want to streamline this process so the video is not 20 hours. All right, so once again, set each and every component equal to 0. So we're going to have 3 equals 0, x minus 5 equal to 0, and x minus 1 equal to 0. So remember, a number that's not 0 cannot be equal to 0, so this is disregarded. All right, then I'm going to add 5. So we're going to have x equals 5, and then add 1 on both sides. So we have x equals 1 and x equals 5. Hello, there we go. Hopefully it wasn't too terrible.